Hello all. Um, this is my first video on the YouTube related to Java and programming. I'm a Java programmer working in industry for a long time. So many times I want to study, but I have to study through my books and through my notes and through my blogs. So this time I thought of creating a video, maybe for myself, maybe for others who need it. So if you like this video, maybe you can give thumbs up and like it and share it. Maybe I get motivated to put more videos in depth related to Java and programming. So let's start. Hello. So today in this video we are going to see about the constructor chaining, about the object chaining, and we're going to see what are the things happens when we create an object, how it calls its constructor, and from its constructor how the super constructor is called automatically. Those things we are going to see theoretically as well as programmatically to have a proof. Now I have just created one presentation here which just gives the brief about what we are going to talk. I will just explain what are the classes we have. Suppose we have a class called the base class or the child class called add, and then the super class of the add is add super, and its parent class is add super duper. Okay, so add extends add super extend add super duper. So these are the classes we are going to have. So we are going to see what happens when we load the class and when we create an object of a class. So here you can see I have created one client. I have created one client class here which is called object chain test. It has three blocks. First is static block, second is non-static block, or the people refer it as instance initializer block. This is the instance initializer block, and third is the main class main method we have. So what happens when we run this? So what are the sequence of events and which of the codes gets executed one by one? We are going to analyze it here, and for our understanding purpose we are going to see how we print which and all what and all logs are printed. Here, as I say, the main method is here, okay, of the test the test client, okay, and we're just going to have similar things will be there in the add class, add super class, and add super duper class. We're going to have three blocks. One is static block, one is instance initializer block, and the third is the constructor block, okay, the constructor of the class. Fourth, I'm just having as a parameterized constructor. We will see how it works there. Similarly, the same thing here, and similar methods are here as well. So what happens? First, when we run this class, okay, as I can show you in this one, when we compile the class, how do we compile the class? Using Java C and the class name, file name .java, and then we will get a class file. We will execute that class file using Java and the name of the class file without giving the class extension. So for example, like this first one, Java object chain test. When we do that, the class will be loaded, the object chain test will be loaded in the JVM. When it is loaded, whenever the class is loaded, the static block of that particular class will be executed, okay, and then once it is loaded or the static blocks are called, then it will call, the JVM will call the class main method, and it has to be there, it has to be the main method. Everyone knows that it has to be public and static because it has to be called with the name, with the help of the reference of the class, so that we don't have to create any object. We will execute and better see it. So let's run this program and see, examine everything, every line and line what happens, and then we are going to go one by one over each and every output. I just run this program. This is what are the printed. Let's see one by one what are things are printed, just to get so that we get a good idea about the flow. First, static object chain is printed. So that means this line, this block is executed. Why? Because when we just call first time this object chain class, object chain test static block of this class will be invoked. So this whatever we are printing in the static block will be printed. So static object chain is printed. Next, the main method is called, right? So the add main will be printed. It's printed here. Next, we have just we did a print out here, instantiating add object, which is printed here, no problem. And then we are creating an object of a class called add. So when we refer that class, the JVM will try to load this class. Okay, so when it loads, it finds that this add also extend add super. So add super will be loaded first. When it loads add super, when it's try to load add super, it sees that it extends add super duper. So add super duper will be loaded first, and then beyond it object java.lang.object. Then when this class is loading, then it's whenever, as we know, whenever the class gets loaded, the static block of that class gets executed. So whatever we have done in the static block of the supermost class will be executed. So what we have done is we have done a print out of super duper static name. So that will be called add super duper static name. So you can see that the name is null, because even before the static block of a class is executed, all the static variables are initialized of that class. So here the static variable we have is a name, whose default value will be, it's a string, so its default value will be null. So hence it is null here. Add super duper static name is equal to null. Then we are initializing it again with initializing it here with add super duper. Okay, and then we have just printed static 1 add super duper, which is executed line by line, it is coming. And then the last one is add super duper static name. And what is the name? So whatever the name we have given here will be printed here. Okay, so this is about the first class which gets loaded. Then we can see here one more static block is here. So all the static blocks are gets executed in the order as they appear. Okay, so this will be also printed. So static 2 add super duper will be printed. Okay, then the call from here, it goes back and try to load. So it was referred by this class. So once this super class is loaded, it will try to load this class, and when it try to load this class, the same thing will happen again. The static block of this class will be loaded, hence these two things will be printed here. Okay, add static super static add super, and static super name is equal to add super. Here name it is taking from its parent. We will discuss more about this in the next video. Okay, but the value it has taken from its parent. Okay, whatever the parent has declared the name is take it. We don't, if we specify the class name dot name, we can use that also. Okay, so once this class is loaded, that means all the static block of this class is executed. It returns back to the for the loading of the class which called. So add super duper was referred by or referenced by add during the loading of the add. Similar thing, static block of this will be executed. Done. Now when we are done loading all the classes and executing all the static block of all the loaded class, now the new variable, new terms, new object will be created. So the process of object creation will start. Now how it happens? Whenever it sees new, it's trying to create the object, it calls the constructor. In our case, we are calling the default constructor. The default constructor is public add. Okay, as we all know, the implicit call to the super default constructor will be made from here. Okay, so hence it will call its super constructor, which is default. Here in this case, add super, it will call the add super default constructor. Again, implicit call to its super constructor will be called. Add super parent class is add super duper, so it will come to the add super duper, and then whatever we print here will be printed. So obviously java.lang.object will also be invoked from here, as we know, because every class or every object uh, super class or the parent ultimate parent class is java.lang.object, so it will be called. And whatever we print here, okay, should have been printed. But what happens is that before anything gets printed in the constructor, the whenever we create an object, the instance initializer block will be executed before you print anything inside the constructor. Okay, so hence here the static the instance initializer block is we are printing add super duper. Okay, so that will be printed. You can see once the static things are completed, I'll just expand it. Once the static things are completed, okay, add super duper instance initializer block is called, okay, this one. Okay, once the instance initializer block is called and finished, then it will return back to the constructor. Okay, and whatever you have printed in the constructor will be executed. So what we have printed here, default constructor add super duper, so that will be printed here. Okay, now the call will go back to the method which we called it. In our case, the default constructor of its subclass called it implicitly. So here the call will return. When it return here, it will do the same thing. Before executing anything of inside the constructor, it will call the instance initializer block of this class. So again this will be printed, then it will come back here, it will be printed. Similarly it will go back to here whatever the instance initializer block is available in the add will be executed, and whatever is inside the constructor will be printed. Okay, and then it goes back here. Now I'll just show the same thing here what we have done. When the class gets loaded, it load like this. The class loading will start from the above, okay, as and when it is referenced, and then when we create object 1 2 3 static block will get executed, then the instance initializer block of the supermost, then the constructor, then this one, then this one, and then this one. This way it will be executing. Now there will be few questions, why static blocks? I'm just trying to explain brief because don't want to, the video seems to be already lengthy. Why static block? Do anything during the class loading, whatever you want to do during the class loading, or any parameter you want to set, any static variables you have to set based on some calculation. Like for example, if the operating system is of this type, then you set some sort of static variables value, and all those things will be done. Similarly, there are other cases like loading the JDBC drivers. There are a lot of values has to be set. That time those values you can put in a static block, and the logging and the security related things also can be put there. What are the limitation of the static blocks? You can't use this super keyword because they are not available yet, because it's all no instance of the class being created, so you can't use them. You can't throw any checks exception because who will catch them? You can't return anything from here because of this, and nobody is waiting to get a value out of it. It's just used for the initialization. And then there are questions like why what are the difference between non-static block, that means instance initializer block. Okay, I'll just say instance init block versus constructor. So what are the things, because most of the time it is confusing that what are the values we should put in the instance initializer block and construct, and what are we have to put in the constructor, because both always look similar, because you have to put something when you create an object, when you want to initialize something, you have to put it there. So both places looks like similar, but there are minor differences are there. One of the reasons to make sure, one of the reasons we have to put the things in an instance initializer block is to make sure that we're not forgetting something. If you are creating a object and you have a different types of constructor, like parameterized constructor, every time for each type of constructor, if you want to set some values, like for example if you have to set the vehicle speed limit, then for every constructor, in every constructor you have to put that value. Rather you put that value in a instance initializer block and don't have to worry about whether each and every type of constructor is doing the same or not. So that way we avoid duplication of the code and avoid any mistakes. So this is one of the reasons which I think about it. Okay.